Okay, so I'm going to make a quick video on how you can copy lines or objects along irregular pathways in order for you to develop a uniform, consistent slope for swales. And this should be able to help you with EX5 and any exercises that you have after that. So what I did is I just set up a quick little line that's going to act as your center line for your slope. This would be applied wherever you direct. Let me set this back, sorry. So, whatever your existing contours would be somewhere in here, and you want to set a, uniform slope, say those are your existings. Those are, a little bit irrelevant once you get to the point of defining, you might gauge your LPS or your HPS, your first number, based off of where it sits amongst existing contours, but you're going to utilize the skills that you gain from the swale exercise, like the road and crown exercise, and any lecture material to figure out how you're going to place those and measure for them and draw your contours for them. But what I'm going to show you is how you can make your swale to indicate, how you space everything uniform and clean. So a lot of the time I like to start by drawing a marker at the top or the bottom, wherever you're starting from or wherever you want to measure from. It doesn't need to be perfect. And then if, this is downhill, in order to create the swale, you're going to have something that resembles, this type of pattern, right, to direct water in. So what's important is that this stays uniform and that the gap between here and here, here and here, that this length becomes uniform, as well as the distance from here to here along the center line of the swale. So I like to either make a tick mark initially at the top or bottom that I'm going to be measuring along. And the command that you use is array. So a lot of you have been using for your contours, have been using offset, and this works great if you're going in a linear straight path or geometric, rectilinear path. For something that is curved, array is going to be a really good tool. So array, R-R-A-Y. And you have a couple of other paths, different methods you can use for array. If you just choose the plain one, it allows you to choose from these within the list of the plain one. So I'm going to choose the one object that if we read the prompt, it says select the object. So the object that you want to copy, so this tick mark is what I want to copy, and I say okay. And then this is those three options. Rectangular lets something copy in a rectangular pattern. Polar allows it to do in a radial pattern, and path is just any line. So path is the one we're going to use. And then we're going to select the path that I want this tick mark to go along. And so I predetermined a 5% slope. This isn't based off of any requirements or anything. I just put a predetermined one just to give something to gauge it off of. So at a 5% slope, you've got 20 feet between contours. If you look, this array has now copied this one line repeatedly along the pathway. Currently, if you look up at your top menu bar, when you click on the item that is arrayed, they're kind of grouped together, and it has a bunch of functions that are always modifiable up until you explode the line work. So currently it says that there are 7 items on the line. There's 12 feet, 0.8 inches, or 0.8 feet in between each of these, and then it tells you the total feet between all of this. So what we want to do is we want to determine the space between them in order to acquire the 5% slope. So basically for your first one, if this is in between contours, you just need to determine that irregular distance that's not going to be exactly 20 initially. And since I made it a whole number, it makes it easier to just know that it's 10. So 10 feet is going to be what's between. So I'm going to go up here and I'm just going to type in 10. And now it has 10 feet between each contour. Now, if you take a polyline and draw it straight from each one of these, it's going to be wrong. It's not going to be exactly 10. But if you draw a polyline with an arc and snap it to your line and you click on it, it's exactly 10 feet along the curved path. And that's what's important, and that's what you're looking for. So if I know at a 5% slope, 10 feet between contours is for a half, so we're going down to 20. If this is the LPS, we're going down. So at this current spot right here, we're going to be looking at our 20 contour. And I might just label that just so that you can keep track of it. Just for the purpose of this video, you don't have to do this. So that's your 20 contour, and your 20 contour would be a major, so we'll go ahead and color it. So you've now, I'm going to delete the original guides. So I like to work from one side down so that you don't have conflicting. If for some reason the spacing of your line doesn't fit an exact perfect slope, it's good to work from one end to the other. So if I know this is where the 20 contour would be, it would hit that spot. I am going to draw something that resembles a swale, whatever formation that looks like. Something like this. And you can make this perfect. You can also, sometimes for swales, I like to draw it, scan it, and trace it. Because to create that organic landform for a swale is somewhat difficult whenever you're working in CAD. There's some stuff that's just better drawn sometimes. It's your personal preference. So I might fillet this and make it like this. And then I'll take this object and make sure that the tippy top of it and the dead center of the swale formation is exactly where that line hits. So that's basically from this point on, it needs to be at a 5% slope. So from here to here, if it's 10 feet, it's 20 feet between whole contours, and that's a 5%. Then the rest of this, we're looking for the whole contours. So I am going to array again with new parameters of 20 feet between each item we copy rather than just 10. So array path. I'm choosing this guy to be copied. Okay, and then the path to curve. So it's now taken it and it starts rotating it through. I'm going to go up to my menu and put in 20 to get my 5% slope. And now you can see my line may stop at a different spot and it might continue on. So you might consider, if you want it to be perfect, you might adjust where your LPS sits a little bit, or vice versa. It just depends, but it's kind of a back and forth game. So I'm going to, after this point, if I know I have exactly what I like and it's good to go, in order to keep, you notice your line work is all one object and one item, and you can modify traits of it with grip points on it. I don't like doing those. I like to control it with just the basic numbers. So you can move it, but it moves as one item. In order to get it back down to individual pieces, I'm going to use the explode command. I've told you all about this command before. Be careful with it. You can really destroy a lot of your line work. Only utilize this in very specific situations. So explode. So it broke up the array, and so now there's no longer grips. It's just the individual lines. And so I'm going to mark this as proposed, and then we're going to start going with these to be, these are going to be each your next foot down. So if this is 20, heck, you could have even, if you wanted to, you could get efficient and you could put your contour labels in the array as well, and it'll allow you to, it would go along and stay parallel with them, which would be kind of nice depending on your workflow. But so this one would be, I'm not going to make these perfect, 19. This one's going to be 18. Just keep track. And 17. Yes, and because this line, CC, where this line ends, is right here, and it continued on. So this line was not in exact increments in order to meet up, and that's probably what you'll draw, right? You're going to draw down a center line of a proposed swale, and it may not be a perfect, even number. So this is 88 point something. I can either adjust and continue my line, so I can do like the extend command or different things. I can extend this center line and meet to that point so that I know it's a whole number. And then my LPS would be at that whole number, which is, I think, 16. Yeah. So then this would be 16. Or you can leave it where it was at and go, okay, so I know that that's not necessarily, a whole number. So then you would have to measure this distance from here to here. You're going to draw a curved line that snaps to it. And so you'll say, okay, that's 18.1. That's my H, my horizontal distance, or my run. And I would multiply that by my percent of slope, so 0.05, in order to acquire your V, your vertical change or your rise. And then that would tell you what to subtract from 17 to determine exactly what this point would be, rather than going all the way down to the whole number. It depends on how much space you have in your drawings and things like that, on which method is the best to go about it. But just utilize your principles that you've seen in your past assignments and lectures. And then this is the command array and offset, and those kind of tools are going to be what you utilize in order to create an aesthetically pleasing looking drawing. You will then take the videos and breakout room references in order to attach these guys to existing contours in whatever manner. So for some reason, if you wanted to, connect this one from here to here, like I do circle, tangent, tangent, and then I would trim these, and now it smoothly connects to an existing contour. Say that was 20, and so the same thing, what you need to connect back, or whatever method you're going to connect it. Say the next one is all the way here. And this is going to vary from plan to plan and whatever you draw, but, so you're going to do something, you're going to start connecting things and connecting them back to your existing. So yeah, that's it.